This map was from earlier in my talk. It's the topographical map of the Northeast. And just as a reminder, the different colors mean differences in elevation. This is a similar map of Western Europe. And you can notice that the topography here is very similar to the Northeast. The graphs look pretty much identical. So Dr. Stephen Long, the director of the International Energy Biosciences Institute, is pretty much the authority on miscanthus and has been growing it for 20 years in some of the countries on the rightermost map. And those are countries such as Italy, Austria, and Hungary. And he has gotten a lot of success in growing it in those countries. And he had the hypothesis that since the climate and topography between the two regions were very similar, that when he came to the United States, he could grow a successful crop. And that's exactly what he did. He came here, and his hypothesis was correct, as he has gotten successful yields of miscanthus of up to 17 tons per acre. And that leads me to my second point. I'm going to compare the energy efficiency between corn and miscanthus. And to do that, I'm going to use the net energy ratio, which is shown here, which just relates the energy output to the energy input for a crop. So unlike an annual like corn, perennials like miscanthus don't need to be regrown every year. They don't need much applications of nutrients. They need less herbicides, pesticides, and water applications. And all that means a lot less time with machinery out on the field and a lot less use of commercial products and all the energy it takes to create them. So according to the National Academy of Sciences, the net energy ratio for miscanthus is 6:1. You get 6 times the energy out of a field of miscanthus as you put into it. Compare that to 1.4 for corn, and all in all, a crop of miscanthus is 4 times as energy efficient as a crop of corn.
So another question that you might have is, why should we choose green roofs over any other method? Well, as we already discovered, urban heat islands make cities have higher temperatures than the surrounding rural areas. And these images show a really great representation of that. So take a look at the picture on your left. That's showing Chicago City Hall with the green roof, and then next to it is a building with a conventional rooftop. Now take a look at the picture on your right. This is showing the drastic difference between the temperatures and the surface temperatures of these two surfaces. We can see the conventional rooftop is reaching temperatures of 150 degrees Fahrenheit, whereas the green roof is only reaching temperatures of about 70 to 80 degrees. So this is a big difference. And the green roof not only has a cooler surface temperature, but it also has cooler air around it as well as inside the building. Another benefit to green roofs is actually the cost. And although green roofs have a higher upfront cost, that cost is then offset by the lower energy bills in the future. Studies have shown that on average, for a 21,000 square foot roof, you can save about $200,000 over the lifetime of that green roof.